Alright, today we're covering translations, reflections, and symmetry. We're going to start off talking about translations, and just to kind of get you in the right mindset, translations are moving figures around on a coordinate plane, and something similar to that to keep in mind would be when you're playing chess, or if someone's tracking how things move on a coordinate plane, how boats are moving through water, things like that. A lot would be very similar to how things are translated and moved from one place to another. Alright, all these things, translations and reflections, and some things we'll get into next week, they're all transformations. A transformation is a change in the position, shape, or size of a figure. Today we're just covering the position, and we're going to start talking about translations. A translation is a transformation that moves each point of a figure in the same distance and in the same direction. Once we have done a translation, you'll be able to see that the image you get after a transformation is an image of the original figure, and we use that vocab image just to keep straight what was the original, and this is kind of a copy of that. To identify the image of the original point A, we use prime notation. So on my figure I'll have point A, B, and C, and when I have translated it to a new point, I will mark this A prime, and that little dash mark at the top, when we say that, we call it the prime. So pause the video if you need to make sure you get all those vocab words down, and then we'll move on with an example. Okay, if triangle PQR is translated 6 units to the right and 3 units down, what are the new coordinates of points PQR prime? Alright, there are a few different ways I can do this. First, I can just draw an arrow, and I can kind of count over from each point. So I'm going to start with Q, just because it's on top. And I'm moving my point 6 units to the right, so that's going to be 1, 2, 3, 4, 5, 6 units to the right, and 3 units down, so I'm going down. Ooh. 1, 2, 3 units down. So my new point Q prime is going to be right there. So Q went from -1, 1, 2, 3, 4 to Q prime, which was 5, 1. And you'll notice my relationship here was 6 units to the right. When I'm moving to the right, I'm adding. So I added 6. And then 3 units down, when I move down on my coordinate plane, I'm going to the lower numbers. I'm going to the negative, so I'm subtracting 3. And -1 plus 6 equals 5. 4 minus 3 equals 1. Take a moment, pause the video, and go ahead and finish drawing our translated triangle, and go ahead and find the new points for P and R prime, and then we'll check your answer as soon as you finish. Alright, so After translating our triangle, we should have found points P and R prime. P prime would be 1, negative 2, and R prime would be 4, negative 1. One last thing to cover with translation is using arrow notation. Arrow notation is just a way to express translation and show it in a written form. So we would just use a triangle to show that triangle PQR was translated to triangle PQR prime. And also point P was translated to point P prime. Just keep in mind that when a point is moved to the right, we're adding to it. When it's moved to the left, we're taking away. Same thing, moving up, we're adding. Moving down, we're subtracting. That pretty much covers translation. So let's move on to reflection. A reflection is a transformation that flips a figure over a line, and that line is called the line of reflection. Like translation, reflections change the position of a figure, but not its size or shape. Alright, so let's do an example. Okay, I'm asked to graph the triangle BCD and its image after it is reflected over the line through 1, 3, and 1, 0. Name the coordinates of the vertices of BCD prime. So this question is asking us to reflect the image over a line through these points. So I'm not asked to reflect it over a certain axis. I'm going to have to draw this line first, and that will be my line of reflection. So 1, 3 is going to be x-axis 1, y-axis 3. So it's going to be 1, 1, 2, 3 here. And 1, 0 is going to be here. So my line through those coordinates is going to be straight up here. That's my line of reflection, and I'm asked to reflect BCD over that line. So as far as a point is from this line of reflection, that's how far it has to go on the other end also. So let's start with C. C is just 1, 2 spaces from the line, so it's going to have to go 2 spaces across from the line. So C prime will be here. B is 1, 2, 3, 4, 5 spaces from the line of reflection, so it's going to have to go 5 spaces on the other side. 1, 2, 3, 4, 5. And it's going to stay, since my line is going vertical, it's going to stay vertically where it was. It's just flipping across the line. So it's staying on this line. And it'll go here. This will be B prime. D prime is just 1, 2, 3 spaces. So we'll go 1, 2, 3 spaces here. And I have reflected my triangle over the line through 1, 3, and 1, 0. I was asked to name the coordinates of the vertices B, C, and D prime. B is at 1, 2, 3, 4, 5, 6. And it's up 1, 2, 3, 4. C is at 3, 5, and D prime is at 4, 1. we have one last topic to cover real quickly. You've done this many, many times before. Symmetry. If a figure can be reflected over a line so its image matches the original, the figure has reflectional symmetry. And the line that divides the figure into mirror images is called the line of symmetry. So, again, you've done this so many times before. Let's say we have a triangle. If this is an equilateral triangle and it's drawn correctly, better than mine, it would have 3 lines of symmetry, because if you flip it over this line, you have a mirror image. Same thing here and here. Again, mine's not perfectly drawn, but you know what a line of symmetry is. A heart has 1 line of symmetry here. Circle has infinite number of lines of symmetry, and so on and so forth. But that's all we have to cover for our lesson today. I hope you have a wonderful night, and I'll see you in class Monday. Bye.